geologist who has been educated, professionally trained, and has expertise recognizing and analyzing geology hazard and adverse geology condition. Their overall purpose is to protect life and property while also resolving geologic challenge. Geology filtrate is the outside class process that gives extra experience to students to get extra knowledge about the subject and get more understanding about rock in natural environment. It necessary to students for their general knowledge in geology field.
Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Muhammad Zahir bin Abdul Rauf. In this part, I will explain about the methodology in our project. I will divide by three parts: data discontinuities, rock mass rating, and rock classification. We go to the first one is data discontinuities. In this project, there are three locations, which are Air Terjun Pandan, Teluk Cempedak, and selected tunnel nearby Sungai Lembing that need to collect the data discontinuities. The data discontinuities can be found by using a Bruton compass, and the total data is 30. So from the data, we are conducted to plot the poles, draw the contours, and draw great circle and find mode of value for selected tunnel nearby Sungai Lembing. The second one is about rock mass rating. As we know, rock mass rating is the process of placing rock into a group or class, so we can find the properties character and such as the behavior of rock that can be predicted. So there are 6 parameters that we have to know to classify the rock. The first one is, for example, unaxial compressive strength, RQD, rock quality designations, spacing of discontinuities, condition of discontinuities, chromater condition, and orientation of discontinuities. So this one is the table that can easy us to find the rating of the parameter. For example, this is the classification of parameter and the rating. The B rating adjustment for discontinuities. C rock mass class and determine from total rating, because this is the final rating that we calculate. So we can conclude the rock either is very good or poor. So this is the also the one of the part that we have to consider to find the rating of the rock. So and the last one is rock classification. It's talk about the how we can know the type of rock, either is igneous, metamorphic, or sedimentary. So we refer to the characteristic. For example, igneous, the structure is glassy, and others characteristic in this table. So for more detail of our rock, we can refer to this chart. For example, igneous. How we can know the mineral composition? We have to refer this table. Also the chemical composition, color, and texture. Next one is the metamorphic. You can also find the mineral composition, parent rock, type of metamorphism, and the structure of the metamorphic rock. And the last one is about sedimentary classification charts. So this is we can also find the details texture and composition of plastic rock, composition of crystalline rock, and mode of origin. So that's all for methodology in this project. This is the data discontinuities at Air Terjun Pandan. In this part of this project, which is discontinuities of rock at Air Terjun Pandan, is need collect 30 value of deep direction and deep angle by using Bruton compass. So when we got the value, we need to present by putting poles, identify the joint set, and find the deep direction and deep angle for joint set. What we have to do, we have to prepare equal area polar net for putting poles, Carlsberg counting net for countering pulse concentration, and equal area equatorial net for plotting pulse and red circle. So this is the result we found at the site. We have total number of 30, value of the direction and deep angle, and then we got this result. This one, we have 30 poles. We plot it using equal area polar, and then we use another tracing paper to get the value of each point by using hexagon shape. After that, we can draw the contour by using another tracing paper. In this case, we use a contour interval 0.5. So we have 7 joint set in this uh, 30 value of deep direction and deep angle. And the last one, we need to draw the great circle to find the deep direction and deep angle. So we have 7 joint set, and then this is the deep direction and deep angle of 7 joint set we found at Air Terjun Pandan. That's all. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Alisha Fariha binti Kamar Zaman. I want to present the result for activities at Sungai Lembing Museum. At the museum, we were given a quiz related to mining in Sungai Lembing and Pahang Consolidated Company Limited. And the quiz is given a total of 30 questions, and all of these questions are shown in slides along with the answers that we searched together while in the museum.
Assalamualaikum warahmatullahi wabarakatuh. My name is Akmal Arif and I would like to share about my part for the calculation of measurement of deep direction and deep angle. As we know, measurement of strike, deep direction and deep angle is to describe the compass direction and the degree of inclination of rock mass. Outcrop is an exposure of rock at the surface or the area of rock lying directly beneath soil cover. What is deep or deep angle? Deep or deep angle is the maximum angle deviation of the inclined layer from horizontal. In other words, the maximal angle of slope is of a tilted stratum measured directly downward from the horizontal plane. The direction of dip is perpendicular to the strike. We get the data from the Sungai Lambing, which is slope failure in front of the tunnels around Sungai Lambing. This quantity data sheet, we have do the 5 joint at there, as you can see in the figure in the pictures, 1 2 3 4 5, and we get the each own deep direction and deep angle for 5 joint. So the slope direction is 262 and deep angle 87. So this is the calculation part where most of failure we have do plane and topping. From joint set data, we assume joint 1 224/41 and the formula for the plane and topping we have referred to the lab 4. As you can see, most of failure, planar and toppling. So the criteria 262 based on the slope direction, plus minus 20 we get to 282 and 242. Deep direction joint is 224. So it is not in range, so it will be unsatisfied. But for the deep angle at 7 degree to 41 degree, this one, and to 30 degree. So it is in range and it is certified. So stability, it is stable because it does not follow the requirement. The plane for plane failure. For the topping failure, also the same, join 1 224/41, and we using the formula from the lab, which is this formula, and we do the calculation part. We get the 87 and 67 plus minus. The direction slope is 262 degree and it is not in range, so it will be unsatisfied. So for the formula, 90 minus 87 degree for the deep angle and plus 30 degree, you will get the value of 33 degree, and it is not follow the requirement, so it will be unsatisfied. But the stability is stable because it does not follow the requirement for plane failure. So that's all from me for the measurement of direction and deep angle.
Hello, my name is Wan Long. In this video, I'll present about the result of the determination of rock mass quality using rock mass rating RMR in the tunnel at Sungai Lembeng. First of all, the step that used to determine the rock mass quality using rock mass rating RMR has 10. The first step is outcrop preparation. First, an outcrop on the tunnel wall with a distance of 1 meter is chosen. We 1 meter because the area in the tunnel is too small. The second step is determine the UCS, Uni Asian Compressive Strength. First, we must use the value of the rebound hammer test, which we use the Swift rebound hammer, and we draw a box of 9, then we measure using the rebound hammer. So the value is shown as this table. So we need to average the value to become the SRV. So we add up all of the 9 value of the rebound hammer value, then divide by 9, then we will get 18.33 SRV. Next, we proceed to this figure or this smooth rebound hammer graph. Our SRV is 18.33, so we draw a line, horizontal line here. And the position that we use is point A, which is here is the rock wall, and then we use the rebound hammer in this direction. So after position A, then we draw a line down. Then we will get 26.5 megapascal of uniaxial compressive strength, UCS. So we can look at the table 1 here. The 26.5 megapascal UCS is at rating of 4, which is at here. Okay, so the next step is determining the RQD, rock quality designation. RQD. The formula that we use to determine RQD is 115 minus 3.3 JV. What is JV? JV is the total number of joints per meter cube. Okay, so here is the formula of JV, which the S1, S2, and S3 here is the average spacing for the joint set. So our data that get in the tunnel is S1 equal to 1 over 6, S2 is also 1 over 6, and S3 is 1 over 4. So we substitute the 3S value into the JV equation. Then we will get like this, which is 6 plus 6 plus 4 equal 16. Then the RQD is equal to 115 minus 3.3 times 16. Then we will get the final answer 62.2 for the RQD value. 62.2 at RQD is at the range of here, which is the rating is 30. Now, the third, the fourth step is to measure the spacing of discontinuity. The average spacing can be determined by using SA is equal to S1 plus S2 plus S3 plus so on, divide by n. Then our S1, S2, S3 is at here. So we total up these three, then we divide by 3, we will get 0.194 meter, which is same as 194 millimeter. Then we can see at here, 194 millimeter is at this range with the rating of A. Okay, so the fifth step is determine the condition of discontinuity. So we can refer to the part E of the table 1, which is at here, part E. The discontinuity length or persistence that we measured by measuring that is 2.5, which is at the range here with a rating of 4. Then for the separation of aperture, we measured is 4 mm, which with the rating of 1. For the roughness of the rock surface is smooth, so the rating is 1. For the infilling or gouge, they are not filling, they are blank, so the rating is 6. And the last one, the weathering is moderately wetted with a rating of 3. After that, we total up this number 4, 5, 6, 12, 15. So the total value of the rating is 15 for this part A4. Okay, so next, the sixth step here is determine the groundwater condition. So for our work, the groundwater is damp. So we look at this table, the damp is at here with the rating of 10. Next, the seventh step is determine the orientation of discontinuity. For our result, the dip angle is 58 degrees struck parallel to tunnel axis, which is at table F here, straight parallel to tunnel axis, and the dip angle is 58. So the rating is very unfavorable. Next, we look at the table B. We are at tunnel. The rating is very unfavorable, which is negative 12. The next step is to calculate all the rock mass classification on the table 1 here. So we can total up it here is the UCS have 4, RQD is 13, spacing is at, the condition here is 15, groundwater here is 10. Then for the result, we can tabulate it like this, which we add up here 4, 13, 8, 15, and 10. Then we minus with the part B here, minus 12, which the value that we get is negative 12. Then we total up all of this number, we will get 38. So the ninth step here is based on the guideline for excavation and tunnel support. So our rating is 38, so it is considered as poor rock. With the excavation, top heading and bench 1 to 1.5 meter advance in top heading, install support congruently with excavation 10 meter from base, the rock bowl 20 millimeter diameter fully grounded with the systematic bowl 4.5 meter long space, 1.0 until 1.5 meter in crown and wall with wire mesh. For the shotcrete is 100 until 150 millimeter in crown and 100 millimeter in side. For the steel set is the light to medium rib space 1.5 meter where required. So here is the calculation of our RMR in the tunnel at Sungai Lembeng. Okay, so that's all from me. Thank you.
Hello and hi, my name is Nur Shamimi binti Norsha. My metric number is DF210011. So today I would like to talk about discontinuities of granite at Teluk Cempedak. So we were asked to take a 13 datars um, to to get its deep direction and deep angle by using a Branton compass and skyline survey. So it is to determine the number of set of joints. So next, how to get the joint set for these granite rocks is first we need to plot our 13 datars that we get from the Branton compass to this equal area polar net. So after we plot all the datas, we can go to Carlsbad counting net, which is we need to count the data by using the pentagon formula to make it easier for our contouring session for contouring pole concentration. So next is our contour that we get after we have done our count in Carlsbad counting net. So after we done with our contour, we need to determine the joint set for each contour. So next is our plotting grid circle, which is we get the contour joint set before, and we need to plot the joint set in this equal area equatorial net for plotting poles and grid circle. So after we have done this, we can get our deep direction and deep angle for our joint set.
Next, I will proceed with the discontinuity of the second rule, which is basalt. For basalt, we also get the task to collect 30 data of deep direction and deep angle as in the table on the left slide. The data was collected using Bronte compass and scanline survey. It is used to determine the number of sets of joints. So, to know the numbers of joint sets, firstly, we must plot the deep direction and deep angle that we collect into the equal area polar net using tracing paper. In the equal area polar net, the deep direction is outside the circle and the deep angle is inside the circle. Then each number of data available on each hexagon is calculated using the Casper counting net. This part will make it easier for us to create contours. After that, the contour can be drawn and be able to know the number of joint sets. Last but not least, after we get the number of joint sets, we must use equal area plotting grid circle to get the deep direction and deep angle for each joint sets. And the table on the right slide is the result of deep direction and deep angle for each joint sets after plotting grid circle.
Assalamualaikum warahmatullahi wabarakatuh. My name is Akmal Arif bin Muhammad Anwar. My number matrix is DF210095, and today I would like to share about my part, which is for discussion for the geology group project. So, geology field trip was held at Sungai Pandang Waterfall, Bukit Panorama, Sungai Lembing Museum, tunnels around Sungai Lembing, and Teluk Cempedak at Pahang, which take 3 days and 2 nights. So from the field visit, the students were asked to obtain the data of slope angle, deep direction, and deep angle to analyze the geological structure that exists in that area. This also will give exposure for the students to know the information for rocks and identify the classification of the rocks. So we have been to the 4 locations at Pahang, which is Sungai Pandang Waterfall, Bukit Panorama at Sungai Lembing, tunnels around Sungai Lembing, and Teluk Cempedak. And each location have each activities. Which is at Sungai Pandang, we have to do the discontinuity of rock. At Bukit Panorama and Sungai Lembing, we have to do the identification of rock, tunnels, rock mass rating (RMR), and Teluk Cempedak, we have to do the discontinuity of rock. So we start at Sungai Pandang Waterfall, discontinuities of rock. So we gather the data by measuring the rock's deep direction and deep angle by using the Bronte compass to estimate the direction from north of the deep with the sharpest declination. It is a way to measure a plane's weakness that, under circumstances, will improve the strength of rock mass. It will encourage and assist the excavation process in much stronger material by affecting the frequency and direction of discontinuity within rock masses. Precaution that we have to take is to make sure that the bubble is in the Bratton compass circle when recording deep variation data, and it is in the Bratton compass line when recording deep angle data. So this is picture. We have used the Bratton compass to get the deep variation and deep angle for the rock. Second one is to Bukit Panorama and Sungai Lembing. We have to do the identification of rock. So from the visit at Bukit Panorama, the most common type of rock that we have found is sedimentary rock. At Bukit Panorama, we could find the different type of sedimentary rocks, which are clays, shale, sands, and gravels. At Sungai Lembing, we have found that the common type of rock is igneous rock. Igneous rock, as we know, is formed through the cooling and solidification of magma or lava. So this is the sedimentary rock at Bukit Panorama, and this is igneous rock, which is being found at Sungai Lembing. So the third location is tunnels around Sungai Lembing. We have to do the rock mass rating RMR. So we applying RMR classification system. The rock mass should be divided into several structure regions and classifies each region separately. We are using 5 parameters to classify a rock mass using the RMR system. The first parameter is unaxial, compressive strength of rock material. 2 is RQD, rock quality design. 3, spacing of discontinuities. 4, condition of discontinuities. And 5 is groundwater conditions. So we received a rating of 4, 21 to 40 for this test, which denotes poor rock. Therefore, to implement the field research, the walls of the tunnel through bedrock must be formed of wire mesh, and the rock box used to support it must be 4.5 meter long and spaced 1.0 to 1.5 meter apart in the ground. So we have to take some precaution that we must alert is we have to handle the rebound hammer with care because it is costly and a little bit heavy. The advantage of rebound hammer test is it is simply to use. And we need some light because the tunnel is very dark to avoid any mishap. Perhaps a spotlight would be preferable because it would make the rock mass rating investigation easier. So this is we doing the RMR test in the tunnel. As you can see, we use the headlamp, and this is the rainbow hammer. So the last question is at Teluk Cepedak. We have to do the discontinuity of rock. So we found that there are two types of rock at there, which are granite and basalt, which classify as group of igneous rock. We found that by looking at the colors and the texture of the rock, which can be seen clearly at the place. Basalt and granite have quite a bit in common. So we were given task in Teluk Cepedak to get the reading of deep variation and deep angle discontinuities, at least 30 data discontinuities for each basalt and granite. So we use the Bratton compass correctly to get the result. And we need to use a cardboard if possible, because it is more it is because we can get the best result by measuring the direction and deep angle. So this is activity that we have do in Teluk Cepedak by using the Bratton compass to get the deep direction and deep angle. And that's all from me for the discussion part. Thank you.
Conclusion: as the result, our students receive a lot of practical information from the geological site visit. From our theoretical studies, we know that practical knowledge of geology site visit is deep more knowledge in identifying rock type such as igneous rock, sedimentary rock, and metamorphic rocks. Since igneous rock may be found at Sungai Lembing, Pantai Teluk Cempedak, and lastly Sungai Lembing Tunnel, we can determine the type of rock based on the place we have been. Additionally, we have a lot of general understanding of the geological structure of the area. We can pinpoint joint and fault much more preciously. Thank you.
Thank you very much.